So moments about the mean. Okay, so let g of x be the real function of a random variable x. Then g of x can be written as x minus x bar power n. Okay, okay. Now here n value is 0, 1, 2, 3, so on. Okay, and x bar is called the mean value of x. X bar is called the mean value of x. Then the expected value of the function g of x. So if you are finding the expected value of g of x, then it is called movements about the mean of a random variable x. Okay, so it is the movement about the mean of a random variable x. Okay, how do we denote this? We denote it as mu of n. Mu of n is used to denote this. Okay, and it is also called, what is n? N is called order of the moment. Okay, and this mu of n is also called the central moment of the random variable x. Okay, so now we'll see what is the nth central moment of x. Okay, the nth central moment of x is nothing but mu of n is equal to expected value of x minus x bar power n. Okay, and this can be written as integral minus infinity to plus infinity x minus x bar power n fx of x dx. Okay, so this is the case for continuous random variable. If you take the discrete random variable, okay, for discrete random variable, the central moment is given as summation xi minus x bar power n. So instead of fx of x dx, here we have p of xi, that is a probability mass function. Okay, so mu of n is equal to summation xi minus x bar power n p of xi. Okay, now if n is equal to 0, so if n is equal to 0, we get 0th central moment. Okay, so mu naught is equal to expected value of x minus x bar power 0. So that is equal to integral minus infinity to plus infinity x minus x bar power 0 fx of x dx. Okay, so you know that this value is equal to 0. Then we left with the integral minus, this value is equal to 1. X minus x bar power 0 is 1. So we left with the integral minus infinity to plus infinity fx of x dx, it is equal to 1. Okay, so that is the 0th central moment of x is nothing but mu naught. Mu naught is also gives us the area of PDF, so its value is equal to 1. So from the previous case and from present case, we can say that mu naught is equal to m naught, that is equal to 1. Okay, now for n is equal to 1, so for we are finding the first central moment. Okay, so mu1 is equal to expected value of x minus x bar. Okay, so that is equal to integral minus infinity to plus infinity x minus x bar fx of x dx. Okay, so this can be, now we write excuse me, we apply this integration separately to each and every term. So we get integral minus infinity to plus infinity x fx of x dx minus integral minus infinity to plus infinity x bar fx of x dx. Okay, so now we know that what is the first integral. First integral is nothing but the expected value of x. This is the formula of expected value of x. Okay, now here in the second integral, x bar is the mean value. So you know that the mean value is always constant. Okay, now we write this x bar separately outside the integral. Okay, now integral minus infinity to plus infinity fx of x dx. Okay, so this value is equal to 1. We know that this value is equal to 1. So the total area under PDF function, probability density function, will be 1. So what we have now, x minus x bar, we will be left with x minus x bar. So what is this value is equal to 0. So from this we can say that the first central moment of x is always equal to 0. First central moment of x is always equal to 0.